Welcome to Civil Concept. In this video, we will learn how to design an isolated footing step by step. Here, the column load is 900 kN and the safe bearing capacity of soil, also called SBC, is 200 kN per square meter. First, we calculate the required footing area. Required footing area equals load divided by SBC. So, required area equals 900 divided by 200. Required area equals 4.50 square meter. Now, we select the footing size. Let us assume a square footing. For square footing, length is equal to width. So, length equals width equals square root of 4.50, that is approximately 2.12 meter. For practical construction, we adopt footing size as 2.2 meters by 2.2 meters. Now check the applied soil pressure. Applied soil pressure equals load divided by length into width. So, applied soil pressure equals 900 divided by 2.2 into 2.2. Applied soil pressure equals 185.95 kilonewton per square meter. Since 185.95 is less than the safe bearing capacity 200 kilonewton per square meter, the selected footing size is safe in bearing pressure. Now let us move to depth calculation. Footing depth is mainly checked for bending moment, one-way shear and punching shear. Bending check is taken at the face of the column. One-way shear check is taken at a distance d from the face of the column. Punching shear check is taken around the column at a distance d by 2. After checking bending moment and shear conditions, provide overall depth of footing as 550 mm and set effective depth as 500 mm. This depth is adequate based on bending and shear safety checks. Now let us design the reinforcement. Provide bottom mesh reinforcement in both directions. Use 16 mm bars at 150 mm center to center spacing in both ways. The footing size is 2.2 meters by 2.2 meters and total depth is 0.55 meters. Now, final checks are required. Check bending safety, check shear safety and check bearing pressure safety. After completing all these checks, the footing design is safe. So, the final design is footing size equals 2.2 meters by 2.2 meters by 0.55 meters. Reinforcement equals 16 mm bars at 150 mm center to center spacing both ways at bottom. Remember, footing design depends on load, soil bearing capacity, concrete grade, steel grade, column size and code requirements. So, actual site design must always be checked by a qualified structural engineer. For more civil engineering knowledge and free civil calculators, visit www.civilconcept.com.